Hello, so this is the third section of chapter 2, and we are going to be looking at radical equations. So before we start, we're just going to recap the previous chapters we have looked at so far. The first section was on just graphing radical functions. So recall again, with this part, we're talking about the function is the square root of x, okay? Then we moved on to 2.2, which was square root a function. So now we have some y equals to the square root, and that function is under the square root. So in 2.2, typically we will graph the function first, and then we just square root all the values. Now in 2.3, we're solving radical equations, okay? So unlike 2.1 and 2.2, where we have some unknown input and unknown output, now we're looking at equations. And when you break down the word equations, there's an equal sign, okay? So in equations, there's always going to be some variable, and you will actually find some number value, okay? So you will need to solve the equation for some variable. So let's look at some examples here. So let's look at this first one. So solve root x plus 3 minus 2 equals to 0. So first we're going to think back to our PreCalc11 days, and we're going to solve this algebraically. So for all these questions, I'm going to have the algebraically method on one side and our graphing method, which we have now learned in PreCalc12, on the left side here. So let's just start with the method we've learned already previously. So before we start, since we have a radical, we need to worry about restrictions. Something about this doesn't look right. Restrictions. Actually, no, I think it's okay, right? Restrictions. All right, so with our restrictions, under a root, the number under cannot be negative. Okay, so we know that x plus 3 must be bigger or equal to 0. So if you arrange this, so x must be greater or equal to negative 3. So that's our restriction. Now we can just solve. Okay, so we have, so let's put our restriction in a box. So it's x plus 3 minus 2 equals to 0. We'll first move the 2 to the other side. And now we're going to just square both sides so we could get rid of that root. So the root is now gone. So we have x plus 3 equals to 4. And now we're just going to move the 3 to the other side. So x equals to 1. So here's our possible solution. But if you recall, we're not done yet because we need to check. So to check, we are always going to separate the right side and the left side. So let's just calculate the left side first. So when we put in x equals to 1 in the left side, left side, we basically have 1 plus 3 minus 2. This is equal to, basically it's equal to 4 minus 2, which is 0, because it's, actually no, let's break that into one more step. So this is 2 minus 2, which is 0, okay? And our right side, well, it was just 0. Okay, and left side equals right side. We're good. All right, let's look at the graphing method now. So when we're graphing it, let me just erase this first. When we're graphing it, when we have, some equation where one side equals to 0, we know we are solving for, we're basically in this case going to look for the x-intercept, or another word before was, roots, x-intercept. Those are what we're looking for. We're finding the solution, specifically the x-intercept. So let's graph this thing. So we're going to just graph this side, and we're going to look for those x-intercepts. So recap again. So this is a radical function. So this is back to our 2.1. Now what do we have here? So this 3 is a horizontal translation, and we are specifically going to the left 3. And this 2 is a vertical translation, down 2. All right, so let's graph this. So our normal radical graph, I'll just draw the radical graph here as our reference. Okay, remember 1, 1, 4, 2, 9, 3, etc. So everything has moved 3 to the left. So this point has moved 3 to the left and down 2. Just 3 to the left and down. So it's gonna look something like so. If you want to map it, by all means, please go ahead. Okay. So that's what it's gonna look like there. So since we are looking for the x-intercept or roots, this point is the one that we're looking for. And this value here is indeed x equals to 1, which matches with what we found algebraically. Okay, so now there's basically 2 ways of looking at the same answer. All right, moving on to the next example. We'll need to find our restrictions. So remember, everything under the square root must be greater or equal to 0. So this time, just to make things easier, I'm going to move the x over because it's already negative. So therefore, we know that x must be less than 6. So now we can continue, we could start to solve for x. So we first have x minus 4 equals to root 6 minus x. We're going to have to get rid of this root first, so let's square both sides. So the root's gone. Now let's expand this left side so we could continue working here. So minus 8x plus 16 equals to 6 minus x. So we want to solve for x. So one tactic when we see a square is to move everything to one side and see what we could do with it. So we have x squared minus 7x. When you move the 6 over, you're going to plus 10 equals to 0. Now, how are we going to find the x? Well, we can factor. So we have x. 2 numbers that will multiply to 10 and add to -7 is -2, -5. Okay. If you have forgotten how to factor, then please review the skill. You have looked at it, I believe, in grade 10 and in grade 11. So now that we have this, we know that with this side, x minus 2 equals to 0. If we set that to 0, then x must equal to 2. If we set this side to equal to 0, then x must equal to 5. So 2 options here. We have 2 options here. But we're not done yet. We need to check. So let's just start with x equals to 2. When we put that in, let's see. So with our left side, we have, if we have x equals to 2, so that's 2 minus 4. That's equal to -2. And our right side, we have root 6 minus 2, which is equal to root 4, which is 2. Is -2 equal to 2? Nope. So left side does not equal to right side. All right, let's try the next one now. X equals to 5. So left side, we have 5 minus 4, which is 1. And right side, we have root 6 minus 5, which equals to root 1, which is 1. This time left side equals to right side. Check. So that means 2 is actually a no-go. X equals to 5 is good. So let's graph this out. So the strategy to graphing this is to actually break this down into 2 separate graphs. So to look at this side as graph 1, and then to look at this side as graph 2. And then basically, once we graph the 2, we will find intersection, where they intersect, okay? So let's start with graph 1. This one is just simply a line, okay? So y-intercept of -4, slope of 1. So it's just going to be a straight line that goes across like this. Again, a ruler would be ideal, because right now my lines are very, very shaky. There we go. Okay. And graph 2. Okay, so graph 2, we need to be kind of careful. So with graph 2, that 6 is kind of in a different spot, eh? So we're going to rearrange it back to the way that we're a bit more familiar with. So if we have, root 6 minus x, let's move the x to the left side and 6 to the right side. So then we're more used to that, the h on the right side, right? Ooh, when we look at this, we see that, hey, we have a negative sign there, which is our b. When we see a b, what do we need to do? Factor. So when you factor out that negative sign, you'll actually have x minus 6. Ooh. So we'll actually need to. So now from here, we have a horizontal reflection. And from this 6, we're actually moving horizontal translation right 6. So our normal radical graph, we have, or our normal square root graph, we have reflected and then moved to the right 6. So I'm just going to graph this one as a reference. You could kind of just as a reference here. Okay, so our point has reflected, so it's now going to we actually have a graph that's going to go this way, okay, and then we're going to move to the right 6. So we're actually going to start at 6, and then we're going to go this way. So it's going to be 1 1 and 4 2, but going the other way, and then 1 2 3 4, and then here's our 3 9. And then there's the 16, but we're kind of wrote into there, so not enough room. Okay, it's gonna look something like this, and then we'll keep on going. And then, okay. So now we just need to find our intersection, which in this case is this point right there. And this one, when you look at the x value, right, it is at x equals to 5. Which again matches with what we solved algebraically. Okay, so if you solve an answer algebraically and it doesn't match with what you graphed, then one of the answers is wrong, okay? So yeah, it should be matching. All right, last one. Okay, last example here. So we're going to go with a very, we're again just going to solve it algebraically first. Let's do that first. So we have restriction. This time we know 6 minus 2x squared must be greater or equal to 0. This time we have to do a bit more here. So let's move the 6 to the other side. Negative 2x. Oh, wait, actually let's move the x to the other side. So 6, it must be greater or equal to 2x squared. We're going to divide both sides by 2, so that goes away. So we have 3 equals, 3 is greater or equal to x squared. And now we're just going to square root both sides. Okay, since we're square rooting both sides, so this side could actually be plus minus, okay? So it's actually plus minus root 3 is greater or equal to x. And the plus minus makes sense because we have an x squared. So even if we have a negative number, you could still square it and it's fine. All right, so here's our restriction. Let's put that in a box. All right, and now let's just solve again for algebraically here. So we have x plus 3 equals to square root 6 minus 2x squared. So first off, let's just square both. So the roots are gone. And let's expand this. So we have x squared plus 6x plus 9 equals to 6 minus 2x squared. And again, we're just going to move everything to one side and just solve the quadratic. So when you add 2x on both sides, we'll have 3x squared plus 6x. And if you subtract 6 on both sides, plus 3 equals to 0. So at this point, it looks like it's going to be one of those scenarios where we have a equals to something bigger than 1, right? But if you look again, hey, we can factor. So let's factor out that 3 first. Then we'll have x squared plus 2x plus 1 equals 0. And then we could factor that below there. So we have basically 3x x 1 1 plus plus equals 0. So at this point, since they're both x plus 1, I can just do one side. X plus 1 equals to 0. Therefore, x equals to negative 1. Check. Oops. Wait. Check. So if we put x equals to negative 1 onto the left side, negative 1 plus 3 equals to 2. And on the right side, 6 minus 2, negative 1 squared. So that'll be basically 6 minus 2. So that'll be root 4, which will also equal 2. Left side equals to right side. We are happy. So this is a go. So let's graph this thing. Very similar tactic. Graph 1, I'll just call this number 1. And graph 2, number 2. So graph 1, x plus 3. So here's the 3, our intercept, and we have a slope of 1. Nice and simple graph. And then this will just go down like so. Okay, there's our first graph. Now our second graph is going to look a little trickier now, isn't it? Because we have that square underneath. So this is one of those square root a function or 2.2 kind of graphs. So first we'll need to graph what's inside. Again, we'll need to rearrange this one a little bit. So then to something we're used to. So if we just take that inside part out, that actually, if we move the x to the left side and the 6 to the other side, we know that it's actually going to be negative 2x squared plus 6. So this is our function. Actually, let me just write that down on the side. So our function here is actually negative 2x squared plus 6. So here we're actually looking at a vertical reflection and vertical expansion. And here we're looking at a vertical translation up 6. So let's graph what this parabola will look like first. I'll graph it in, I will graph it in green actually then. So it's a parabola that's upside down, that's moved up 6. So that's 1, 2, 3, 4, 5, 6. And it has a vertical expansion of 2. So instead of 1, 1, it's going to be 1, 2. And it's upside down, so it'll be like that. And then instead of 2, 4, it's 2, 8. 4, 8. And instead of 18, I don't think I have enough boxes. So let's just graph it. Okay. Whew. Okay, so there's our parabola. But keep in mind, we're not done yet. So actually, I'm gonna change the color of this to red. So I graphed the inside function in green, but I still need to square root all the points. So let's root these things. So remember, invariant point at 0 and 1. And then just find some other key points. This time it works out quite nicely. We have y equals to 4. So I'll just bring it down to 2. And square root of 6. I don't have that memorized by heart. It is 2.44. So somewhere there-ish. Okay, so now it's just connecting the dots. Okay. Oops. So there's our graph. And here, that dot that I'm making very massive, here is our intersection point. And there is, well, you might have guessed it, x equals to -1. Yay. So that is the end of this section of radical equations.